This is lesson 4.1, Introduction to Polynomials. This is the first lesson of chapter 4, which is all about polynomials. And this lesson is essentially just definitions, then we'll do a couple examples at the end. So first definition is algebra. Generally, algebra, you would have worked with this last year, and this is just a branch of mathematics that uses symbols and numbers to represent unknown values. So algebra is extremely useful because most problems have an unknown value and some known values. You need to use them together to figure out the solution to the problem. A variable, this is just a letter that represents an unknown. So often we use X, sometimes Y, Z. It doesn't really matter what the letter is, it just represents an unknown. That's a variable. Coefficient, we talked about this in chapter 3, and that is just a number that's in front of a variable. It represents how many of those variables exist. So for 3x, 3 is the coefficient and x is the variable. There are 3 of those x's. For negative 7y, the coefficient is the number in front, so negative 7, and the variable is y. There are negative 7 of the letter or the variable y. Constant, there's a difference between coefficient and constant, but a constant is just a number on its own without a variable. It's called a constant because it constantly stays the same. It does not depend on x or on any other variable. So example 6, negative 1, 2, just any number that's standing on its own is a constant, but a number in front of a variable is a coefficient. A term is a single number or a single variable, or a number and variables, those multiplied together. So I have 4 examples here. A term could be 2x, so one number and one variable multiplied together. It could be just negative 3, so just a single number on its own. It could just be y, so a single variable on its own. Could be, 45z. It could be 3abc. A term is just one thing together where they're all being multiplied, and it's a combination of numbers and variables. Terms are separated by addition and subtraction in algebraic expressions. So this is an algebraic expression. We have 2 terms in it. We have 2x and we have 3. This is not considered one term because the addition symbol separates the 2 terms in this expression. So terms are always getting multiplied together, but when you have addition and subtraction, that's separating your terms. So in this expression here, we have 3 terms because we have 3 different sections that are separated by addition or subtraction. So the first term is negative 7x. Don't forget that negative in front because that's part of the coefficient. The second term is negative x. The third term is positive 2. A polynomial, or the main thing we're going to be working with for this whole chapter, is an algebraic expression with one or more terms separated by addition or subtraction. In other words, the 2 things that we just looked at, those are considered polynomials. So another example, 3x minus 4. These are 2 terms separated by subtraction. 4z, yes, this is only one term. So there's technically, it doesn't have any separation from addition or with addition or subtraction from other terms. But it's still a polynomial because it's just one term on its own. Remember, this definition says with one or more terms. Same argument goes for 6. Again, that's just a constant on its own, but it's still considered a polynomial. There are 3 different types of polynomials: monomial, binomial, trinomial. They're kind of easy to remember if you just look at the prefixes of the word. So a monomial is a polynomial with just one term. So 2x or 10. There's no addition or subtraction separation here because it's just one term on its own. So this one and this one, those are both monomials as well. A binomial, prefix bi, is a polynomial with 2 terms. So 3x minus 1. This is a term and this is a term. It's separated by the subtraction. Or 4 plus 6x, one term here, one term here, separated by addition. Then you could guess a trinomial is a polynomial with 3 terms. So we've got 1, 2, 3, 1, 2, 3. Of course, sometimes polynomials will have way more terms than this. It could have 5, 6, 10 terms, whatever. But any polynomial with 4 or more terms is just called a polynomial. There's no special name for them. I'm sure there maybe is a special name somewhere, but we're only going to look at monomials, binomials, and trinomials. So those are all types of polynomials, but they specifically have another individual name based on how many terms there are. The last kind of new thing to learn here is degree. First, we can find the degree of a term. We do this by adding up the exponents on the variables. So chapter 3 was all about exponents. We know how to work with those. To find the degree of a term, you just add up all the exponents that exist, even if it's 1. So in this first example, the exponents on the variables, we've got 2 and we've got 3. So this degree would be 5. But in this example, technically there's no exponents written. It's just x, y, z. But remember, if the exponent is not written, then it has exponent 1. X is just equal to x to the power of 1. So this degree would be 1 plus 1 plus 1 would be 3. Because really there's a 1 on each of those. It just doesn't change anything, so we don't write it. It's redundant. What about 6, though? This is a constant on its own, and there's no variables. So this has degree 0, because there's no exponent and there's no variable associated with this. The degree of a term is when you add up the exponents on the variables. So if there's no variable, then the degree is 0. Last part, to find the degree of a polynomial, you just look at the degrees of each of the individual terms and pick the biggest one. So whichever the highest term degree is, that's the degree of the polynomial. So in this example, we have 3 different terms. This has degree 3 because 2 plus 1, the one that's not written there. This has degree 4 because we've got 1 plus 3. And this has degree 5. So overall, the degree of this polynomial is 5 because that's the biggest number of the ones we just found. A common mistake might be to add all of these up. So you would say 7 plus 5, oh, it's going to be 12. But no, you just take the highest term degree. That's the degree of the polynomial. So one example, just to throw all of this together, we have a polynomial here. Let's label it with the parts that we know. So this is a term, this is a term, this is a term. We've got 3 terms here. So what I wrote here is the whole thing is a polynomial. This is a polynomial that we're working with. But more specifically, it's a trinomial because there are 3 terms. Okay, we know that much. Let's use a different color. X and Y are the variables here. So I don't think I'll label that actually. I just have it written here. But the variables are X and Y. The coefficients are the numbers in front of the variables. So -4 and 3, those are our coefficients. Because these are the numbers in front of the variable. And this is different from 5 because 5 here is a constant because there's no variable associated with the 5. It's all on its own. So we've got all of that. And then the only thing left is the degree. So we would find the degrees of the individual terms. So the first degree is going to be degree 2 because we add up the invisible ones on both of the X and Y. The degree of the second term is 3, and the degree of the last term is 0 because there's no exponent. So then we pick the highest one, and that's the degree of the polynomial. So the highest one is 3, so therefore the degree of this polynomial is 3 because that's the highest value. So that kind of takes everything we've learned and put it into one example. If this had 2 terms, it'd be a binomial. If it had 1 term, it'd be a monomial. If it had 4 or more terms, we would just stick with calling it a polynomial. We wouldn't give it another specific name. And that's polynomials.